So thank you very much for waiting. There are always unexpected troubles when you try to do something new. Actually, we have practiced it before this occasion, but it's not always possible to avoid unexpected trouble. All right. So today's topic is is entitled "Easy and Lazy Technical Writing and the Presentation: A Step-by-Step Guide to Establish a Good Logical Structure." So I would like you to understand my message is that I would like you to learn how you can prepare your draft of a paper very easy and also in a lazy way so that you can make your life more efficient. Okay, so technical writing may not be easy. Well, you should, of course, agree with it. You should have experienced many difficulties, probably. And you will be surprised to see even invited speakers, I hope I am not included, those are often bad in presentation because you do not know how you can do that, how you can make good presentation. Neither does your boss. So even if you ask your boss how you can do that, it is not always possible. Most of them are not good at telling you in the most efficient way. So you should know the most efficient way by not asking your boss, of course. Lectures and books teach what? They do teach what you should do. However, the problem is that they don't tell you how you can proceed. And feedback is a very useful thing. It's a must. You need consultation. And this talk teaches how you should proceed. So that's the biggest difference when you compare this talk with other books and talks. I will mostly talk about technical writing and slide preparation, primer, the basics. I will also talk about typical patterns and useful techniques for drafting. Right? So the contents are like these, but I don't think I will talk about this stage. And let's think about the efficient paper writing. First, you should read technical writing books and practice what are written there in the books. What I have been proposing is to start with slides. Slides first. That's very important. Assuming a lecture. So let's assume you will make a lecture and then prepare slides. The most important thing here is to keep the font size bigger than or equal to 24 points. And this is very good. This is very useful for eliminating redundancy. Otherwise, you will prepare your slide very congested. That is not good. But if you use this font size, you cannot put as much as you want in many cases. So that's a good thing, so that you have to remove redundancy. And you can highlight the points of your presentation. It's also recommended to have your draft reviewed by others. If you simply draft it by yourself, it's not good because your view is usually one-sided. And keep writing for practice. Everybody says it. You cannot make something in the same. Writing for practice. You need practices to get better. What is good logic? I often use this expression, good logic, but it is not easy to find, or even impossible to find the definition of a good logic. What is good logic? First of all, I can explain it in this way. It is easy to follow. When you write something, it's easy to follow without any question or rethinking. This is a sign of good logic. Or I can also tell you in a second way, it is possible to predict the next content. When you go through a paper or any written thing, so with slide first, you should first do page allocation because you have the number of pages is limited. It's not infinity. And use a template, especially true for a novice when you have little experiences. You want to experience it's easy to follow a template as far as the template is designed in a very way. Establish a good problem-value pair. This is a very common fault when we are reviewing papers submitted to conferences and journals. If there is not a good pair of problem and value, it is very easy for us to decline or reject that paper. So in this case, paired words often help, which I am going to talk more about in the following pages. Select figures and tables to use. This is the first thing you should do when you prepare slides. Pick up which one to use, because you can put everything. Generally. Fill in necessary information in each page. And then balance slide allocation. And also within each slide, you can balance the contents. And then finally, reorder slides to modify the logic if it is necessary. And it's very easy. That is a major reason that why I recommend that you first prepare slides. Alright, this is an example of paired words for values and problems. On the right hand side of this page, I put positive words for the value to describe the value of your research, the value of your paper. On the left hand side, I put negative words for the problem. And when you look at each column, for example, when you look at this column and this column, they make a good pair. For example, when you look at computations is one of the problems when you design or when you assemble a practical system. You would like to have a small number of computations. An opposite word to computations is efficient. Because when you have big number of computations, it's a sign of inefficiency. Or you can also directly say inefficient, which is also opposite to efficient. Or any of these words like compact. If you design a system with a smaller number of computations, you can use a smaller number of LSIs or chips so that the whole system becomes smaller. Okay, so this is an example. The point is that this is what I designed for myself. So it applies to my own field of research. You should prepare a similar thing which covers your field of research. So you cannot use this unless you were exactly in the same field as mine. But you should prepare yours by your own. Now let me talk about page allocation. So how many pages for what? This is what it means, page allocation. Right? Usually 10 to 15 pages you will have, assuming that you have 10 to 15 minutes presentation. So here, let's assume that you have 10 pages, and page 1 is usually used to describe the background of the research. Page 2, you will put conventional method. In page 3, you will find problems of the conventional method, which is quite relevant to what you're going to present in the paper. In page 4, put point and rationale of the solution. Rationale means why it works, the reason. In pages 5 and 6, details of the solutions you will put, followed by pages 7 through 9, where you will write conditions and results of the evaluation you have performed in the course of the research. And in the final page, that's page 10, you will put a conclusion or a summary. This is the general structure of a presentation, assuming you have 10 pages. Alright? But the question is, where to start? Alright? Although presentation, preparation. start from page 1 because it's basically the most difficult page. Start with pages 5 to 6. Details of the tree for the value. What is the value? I'm going to go details about these two words. And page 4 follows pages 5 to 6. Point and equation of the trick. Trick is actually what you are going to propose in your paper. In page 3 comes up next. Problem of the conventional method. Because there is a problem which you are going to solve, you will write a paper or you will make a presentation. So that comes up in page 3. And then you will move on to page 2 where you will describe the conventional method. What is the conventional method? Why it is good? What kind of problem or problems it has solved? In pages 7 through 9, you will put evaluations, including the conditions and also the results. This is very important. Now it's time to go back to page 1, where you will describe the background of the research. Because this is the most difficult part, even though you may not think so. This is very, very difficult because it does serve as the position of the paper. So depending on the position of your paper, the background will be very much different. In page 10, you will write a conclusion or summary. Okay, so that's the order of preparation. Now, let's talk about the key to the success, how you can succeed in your paper writing or your presentation. So as I have already said, problem value pair is the key. This is most important, the single most important thing to be successful in paper writing. I propose to follow or practice this, which I call 3-point analysis. The first one, first in the word. Let's clarify the first in the word. That is the value of your research. Value of your paper. This is the most important thing. Your contribution is the value of your paper. Okay, contribution, achievement, or benefit for the user. As far as you are in engineering, there should be something, some benefit at least, because that's what engineering is. Number 2, identify a solution, or you may call it a trick. This is must for the value. Because of this trick, you can achieve this value. So that is what solution means, or a trick means. It may include a function, new function, a structure, component, a process, or ingredient when you're working on devices or support. Number 3, identify the problem you have solved. Okay? This is actually opposite to the value. Because you have already identified the value here, it's very easy to identify the problem, as I will show you later. And again, the value and the problem, they should make a good pair, 1-to-1. So when you are ready, when you have performed the 3-point analysis here, ask yourself if the trick naturally reminds of a solution to the problem. Of course, your answer should be yes. To proceed further. Okay, key to the success. Again, the same thing. It's a review of the previous page. Problem value pair is the key, as I said. And ask yourself, what is the value achieved by your research, by what you're going to write in the paper? And then ask yourself, what is the trick for the value? What made this value possible? That is the trick. And number 3, what is the problem? This is the next thing you should ask yourself. And as I said, this is opposite to the value. So once you have identified the value in a good way, it's very easy to identify the problem. And then, what is a conventional method? It's a kind of review in yourself too, because you should be familiar with the conventional method. the general application or application with respect to daily life as far as you are engineering, because that's the value of engineering. Okay. Then, if you follow this way, your introduction should look like this. So in the top part here, at the top of it, you have how the value benefit the daily life. And second, from the last paragraph, you have a problem which has been solved by your research. Okay, so these two things are very important. And then in between, you will put the background, that is the paper position, with past papers. Intermediate paragraphs are devoted to describe past research, relevant researches, relevant reports, consisting of who, or sometimes when, did what, and how it was. Of course, it was good. It must have been good. However, any relevant conventional method, conventional research report, they should have at least one problem. That's why you are performing your research. And that's what you are going to write in the paper. Okay? And then when you come to the second last paragraph, you will clarify, you will describe the most relevant method, most relevant research, conventional method. And then you will go to the last paragraph, which tells the real structure of the thing. Now, let me talk more about the three-point analysis. As I said, you will clarify these 3 points. First one, value of the paper. The second one, trick to achieve the value. The third one, the problem will be solved. These are the elements of the three-point analysis. And then, once you have performed the three-point analysis, it's very easy to design a good title on the paper. Once you have a good title on the paper, and then it's easy, it's just a straightforward step to design or to draft the topic sentence of the abstract. Topic sentence is the first sentence in the abstract. You can utilize the title of the paper so that it becomes very straightforward. You don't have to worry about it. You don't have to spend all the time. It's just a snack. And then, again, make sure what is the most relevant method, what is the most relevant research convention. Alright, so this is what I call a three-point analysis sheet. The first thing, ask yourself, what is the first in the world, which is the value of your research? Ask yourself, what is it? And the important thing here is to put the value of your research in this specific box without changing the font size. Here, the font size is set to 36 font, which is quite big. You will easily find it is not that easy to put the value here in this box because the size of the box, length of the box is limited. The font size is relatively large for this box. That means you need to think about many times what is the real value and what is the most efficient expression to convey its real meaning, and try to select an appropriate word which is short enough to fit this box. Usually you should spend a very long time to identify this value. There are many possible ways to express your value, but there are only a few ways to make it very impressive and effective. Now the second thing is, what is a trick or function to achieve the value? Trick is something which you cannot miss to achieve this value. So this is what you like to emphasize, because this is what you have noticed, what you have found, which have been unavailable until you notice somebody happy or many people make happy, make their lives more convenient. So ask yourself this, so that you will be able to find the value of your paper or your research. It may be a new function to enable something. It may be some better accuracy or stability to achieve better performance. It may provide wide applications so that it becomes versatile. It may provide quick start so that everybody will be happy. And it may also be a structure or a algorithm, like production structure, production algorithm, calculation algorithm, or even maintenance. In this case, it should be simple or parallel. It may be implemented in parallel so that it will be more efficient, and it may have some regularity or symmetry, both of which are important from a viewpoint of engineering, because you can reduce the cost of manufacturing if the system has regularity or symmetry. Okay, the next topic is a trick. What is the trick? It's a solution to bring the value. It should naturally lead to the value. When you think about the trick and refine its expression, the way to describe it, always think about this: if the trick should naturally lead to the value one. Of course it should. And then trick may include a new component, a new measurement, a new measure for an index, a new process, a new equipment, new or equivalent model or structure, new cost. For example, in optimization, if you introduce a new cost, the optimization result will be different. A new ingredient or ingredients. Sometimes redundancy removal may be counted as a trick. So these are examples of the trick. The next thing is the problem. This is again opposite to the value. So once you have identified the value of research, and then it's easy to identify the problem. The problem is identified in the most relevant research. Okay, so the problem is what the most relevant research has in itself. So that's why you are going to solve it. That's why you have solved it. And the problem may be identified in an application. So the problem you may be finding in your paper, it may not be totally new from a viewpoint of technique, but if you apply it to a new application or in a new field, that's also a problem you have solved. And multiple relevant research may exist sometimes. The value is obtained when the problem is solved. So that's what it means. This is a sheet to help you identify the problem. What is the solved problem? Once you have identified the value, start with the value which is okay, because it was in a previous page. Express the problem with A. A is the value you have identified, plus no or not, negative or. And then, once you have done that, once you have obtained this expression, express this one without
And sometimes you may not find this one. It may not exist. All right, once you have performed three-point analysis, you have value. I feel some echo, acoustic echo. So once you have identified the value, the trick, and the problem, sounds very interesting. いいですか? はい. So the title of your paper will be designed like this. You don't have to worry about it because it's a simple combination of A and B. A is the value and B is the trick. You can combine the value and the trick in the order like this, A plus B, that means A followed by B, or in the reverse order, B followed by. And it is possible to use up to one conjunction to combine A and B. And in some cases, it is better to use yet another word to make the expression more natural or much better. So in that case, in the next step, you may introduce another word to make the title better. But still, you should put everything in these two boxes. Now there are two components, A and B, so that's why I am allowing two boxes, not only one. And then once you have designed the title of your paper, the topic sentence, which is the first sentence in the abstract, can be designed like this. So unless you are very experienced, always start with this paper. Don't think about any other expression. Always start with this paper, followed by proposes or presents. When you are proposing something, it is effective to use propose because it's a very strong expression. And present is a bit weaker compared to propose. And sometimes you are not proposing. For example, when you are writing a paper to tell the evaluation results, you are actually not proposing something new. However, you are showing something new. In that case, it is recommended to use present as the verb instead of propose. Okay, so that's a simple difference. Let me repeat it again. Always start with this paper and use propose or present. That is a key to a successful abstract. So that it looks like this. This paper proposes or presents, plus the title of your paper. It's very easy. You don't have to worry about it. You don't have to think about it even. It's a very simple task. It's just a combination. You can finish it within 3 seconds. Okay, now it's time to review and confirm what is the most relevant research. Sometimes you may have to change the most relevant research once you have designed or once you have completed up to this step. If the position changes, position of your paper changes, the most relevant research may be different. So it's worthwhile to check again the most relevant research at this stage. All right, let me give you an example. Otherwise, it is not easy to understand for some of you, or maybe all of you. These guys, you know, you should be very familiar with these guys. They are Nobel laureates. They received the 2014 Nobel Prize in Physics for the blue laser diode, their work on blue laser diode. And I am going to concentrate on this person, Professor Nakamura, Shuji Nakamura of University of California at Santa Barbara. This is his contribution. Okay, let's look at it. Don't worry, I'm not a device expert either, but it's very easy. And his research is very clear and a very good idea. You will be surprised to understand it. Okay, let me talk about it. So in this case, of course, he wanted to fabricate a good quality, high quality blue laser diode crystal. So this is a reactor where everything happens. Any chemical reaction happens in this reactor. He was sending reactant gas consisting of nitrogen hydrate and TMG. TMG means trimethyl gallium, which is a metal, paper metal, perhaps. And by sending this reactants gas, he wanted to fabricate a thin film of gallium nitride over a sapphire substrate. This is a crystal film. This is what he wanted to do. However, the problem he identified is that the reactant gas actually does not reach the substrate. It does not reach the substrate. It will not form the crystal film. So that was the problem he wanted to solve. And there were, of course, so many people competing to develop a new method. So the fact was that reactant gas was parallel to the substrate because it's coming in this way. It's parallel to the substrate here, sapphire substrate. And there is some diffusion. So when the reactant gas comes out of this tube, it goes up, it goes away. So not all of the reactant gas touches the sapphire substrate. So there was one proposal by Professor Amano, who is also Nobel laureate at the same time. So he introduced a vertical tube here called the delivery tube. So this tube sends the reactant gas to the surface, to the vicinity of the sapphire substrate, perpendicularly, so that there are more chances for the reactant gas to touch, because it is not in parallel. It's perpendicular to the sapphire substrate. However, in this case, there is yet another problem because it goes to the substrate. There is a non-uniform deposition. It touches very strongly at the center, and then it diffuses around. So that's one of the reasons why there is non-uniform deposition. So he further introduced, Professor Amano, he introduced a slanted position of the sapphire substrate. At the high flow speed. So there is a direct contact of the gas, reactant gas, with the sapphire substrate. So let's review this new system. The tube, delivery tube. This is good for non-diffusion. The reactant gas will not scatter. And high-speed gas, there is no diffusion. It also contributes to no diffusion. And angled substrate. This is also good compared to the structure consisting of parallel substrate and the reactant gas flow. Now, let's perform three-point analysis. What is the value? What is the first in the world in this case? The work by Professor Amano, not by Professor Nakamura. Blue laser diode crystal fabrication by MOCVD, or high-quality crystal, you may say. That is the value. That is what he made possible. And what is the trick? it's clear. He introduced a delivery tube so that the reactant gas will not scatter. The reactant gas is sent to the vicinity of the substrate surface. And what is a solved problem? It's opposite to the value. So simply introduce no before the value. So no blue laser diode crystal fabrication by MOCVD. By the way, MOCVD is the name of the method, whatever it is. So this is the sheet to identify the problem, but we have already done that. Let's skip it. Now, there is a person called Taichi Ono, who was a former executive deputy president of Toyota Motors Manufacturing Corporation. You know Toyota, which is one of the top three giants in car manufacturing in the world. Last year it was #1. This year probably Toyota will be #1 again. 2 years ago it was GM Motors. Anyway, so he kept saying, find the root cause of the problem to fix it. You need to find the root cause, not simply a cause, to fix the problem you have. So the problem in this case, in this blue laser diode case, is the crystal is not deposited. Crystal is not fabricated. I mean, good crystal, high quality crystal. And the cause one they have identified is the reactant gas is not delivered. That is the cause. And the solution is gas delivery by delivery tube. It's very straightforward, and it's a good solution. Now, he said, find the root cause, not simply a cause, so that it's a motivation for people to ask yourself, again, why it happens. Why this happens, the cause one. Why is the reactant gas not delivered? That is the target of second why, and the second cause identified by Professor Nakamura. In this case, it's Professor Nakamura. He identified that reactance gas goes up. It does not simply diffuses, but it goes up. So that's the key. And he introduced a solution of pressing gas. So let's look at this figure. The reactant gas sent into the reactor goes up. So the solution proposed by Professor Nakamura is to press down this reactant gas like this, so that it touches the sapphire substrate to form a crystal film. And this is an actual structure. There is a funnel-shaped tube so that it will press the reactant gas more efficiently. By the way, this pressing gas is neutral so that it will not do anything from a viewpoint of chemical reaction. It simply presses down this reactance gas. So this is what Professor Nakamura received his Nobel Prize. Okay, let's apply the three-point analysis. The problem is the value is the same. The same thing is achieved. Maybe the quality of the crystal is better compared to the one obtained by Professor Amano. And what is the trick? It's very simple and straightforward. Pressing gas. It's a very good solution because it's simply opposite to the cause identified. The gas goes up. That's why you need to press it down. Up and down, it makes a good pair. And what is the solved problem? The same thing, no blue laser diode crystal deposition by MOCVD. Or if you look at the work by Professor Amano, delivery tube in blue laser diode crystal fabrication. This is the problem, and this was removed. Of course, it is more expensive to have such a tube, and you need to design it carefully in the reactor. It's another view. Okay, so title of the paper by Professor Nakamura could be the combination, the combination of these two things, the value and the trick. So blue laser diode crystal fabrication by MOCVD with, this is a conjunction, NH3 delivery by pressing gas. But in this case, NH3 delivery is not very important, so you may skip it to say simply blue laser diode crystal fabrication by MOCVD with pressing gas, because pressing gas is the trick, it's important compared to NH3 delivery. Okay? And once you have obtained the paper title like this, as I said, all they have to do is to combine the leading phrase of the topic sentence. This paper proposes, in this case, let's use propose because this is a completely new technique. This paper proposes a blue laser diode crystal fabrication by MOCVD with pressing gas, or with NH3 delivery by pressing gas. This is good enough for the topic sentence in the abstract. Okay, either one is fine. And this is the most relevant research by Professor Amano. Okay, so let's review how you can design the abstract. The first one, the topic sentence, as I already talked about, it's a combination of the trick and the value. It's simple and straightforward. You don't have to worry about it. The next thing you should put in your abstract is the trick and the effect. What is the trick and how it works in a single sentence. This is a kind of summary of your contribution. Effect is the other side of a coin for the problem. And then after this, trick details, because here in a single sentence you cannot tell the details of the trick. You may simply put the name of your trick, but you would like to tell the details, and it's necessary. So trick details can be expressed here equal to or smaller than 2 sentences so that it would not be too long. It is important to put the rationale, why it works, why your trick works. In the case of Professor Nakamura, the pressing gas presses down the upcoming gas so that its movement is quantified. Okay, so it's a kind of rationale. You may express in a similar way as a rationale. And it will be very clear for the reviewers or for the readers why it works. And then you should also put the evaluation results. Without the evaluation, it is simply a theory and nobody will believe in it. Single sentence, numerical values, which are often missed by many people. Don't say simply, this is better, this is good, or this is faster, or lighter, or simpler. Never say that. If it's better or not will be left on the reader's hand. You can simply put the value compared to the conventional research result, and they will evaluate if it is very good, or it is fairly good, or it is comparable, or it is not effective at all. Okay, so it's very important to include the numerical values, or at least a numerical value, but a numerical value for the proposed method and another value for the conventional method. For comparison, at least you will have 2 values here. And one more thing is to use the present tense. You may wonder why, because you have already finished evaluation. But always the subject is this paper, and this is a fact. To describe a fact, you are supposed to use the present tense. That's why. Okay, it is often a question. This is a common question. If you should start with a problem or even a research history in the abstract, I would say 65% or 70% of the abstracts in a paper start with a problem or sometimes with a research history. Is it good or bad? It's a difficult question, maybe, but it's simple. Who will read it? Readers, true. But before readers, reviewers will read it. And they are basically familiar with what's going on in that field. So what do reviewers do when they perform review of papers? So they first go to abstract for the trick and the results, because they are most interested in what kind of new technique you have introduced. And then they will go to introduction, basically second to the last paragraph, for confirming the problem which has been solved. And they will go to the evaluation section for validation, how good it is they would like to see to validate the new method or a new system. So, keeping these in mind, it is not recommended to start with the problem or even a research history in your abstract, because there is no information on novelty or originality of your research. It is not included in the history, or it is not included in the problem. And busy reviewers are frustrated because they are always searching for the novelty and originality and how effective it is. So they are frustrated. And the space is wasted on the problem. Reviewers would not like to read about the problem. They are more excited with the trick and how effective it is. So that's why space is wasted, and lack of information on the trick you may face. Why? Because you are spending precious space to describe the problem or a research history. And then you will have much smaller space to describe your own trick, which is much more welcomed by the reviewers and the readers. Okay, from here, usually I talk about the structure of the paper, but I assume most of you are familiar with it, so I will just skip it. And sometimes I will make a brief stop to make some comments. Abstract, I have talked about it, and these are some useful expressions and introduction. Maybe this is some important information for you. I understand you have many chances to write a very short paper, like single page or 2 pages. In that case, you cannot spend 1 page or 1 column as introduction. So in that case, how you can design your introduction? You cannot put everything. So in that case, follow these steps, which I call the 3-sentence introduction. You will use 3 or 4 sentences to form your introduction, so it fits within a single-page paper. What has been presented as a conventional method? So this is a single sentence. Describe this with the advantages and the reference. The second sentence is devoted to the existing problem. What is the existing problem? This should appear as the second sentence. Describe the problem or sometimes problems of the conventional method. And then you will write what is the topic of the paper. And you can use the topic sentence of your abstract as this sentence, the third sentence. It's just a simple combination of this paper proposes or presents followed by the paper title. It's very simple and straightforward. So let's count 1, 2, 3. There are only 3 sentences. Sometimes you would like to include 1 more sentence to describe the problem or the background. But even in that case, you have only 4 sentences. It's short enough to fit within a single page paper, right? So this is a technique. If you follow these 3 steps, you can make it within a single page. If you are writing a long paper, and then you can simply make each sentence as one paragraph or multiple paragraphs so that you can spend more volume. Let's see. And body, patterns, conclusions, acknowledgement, references, appendix. Okay, let me talk about tips for good expressions. This is a very common mistake. If you are not experienced, your sentences are likely to be long. Sometimes it spans, a single sentence spans 3 lines or even 5 lines. It's very long. In that case, there are multiple pairs of subject and verb. With a high probability, you are describing 2 things which are not closely related. That is not good from a viewpoint of logical design. To avoid it, 1 sentence for 1 content. This is the rule you should follow. A single sentence for multiple contents makes a twisted description. Sometimes a combination of the subject and the verb, they are twisted because you are naturally assuming the same subject, but actually you are describing something different. So it happens quite often when you are unexperienced. The second thing, avoid multiple ofs in a single sentence. Sometimes you need to use it, you cannot avoid it, but up to 2. No more than 2 ofs in a single sentence. Instead of using of, you may use different expressions. Sometimes you may use different words instead of like at or after or with respect to or something like that. The third topic, tips, no redundant expressions. It's quite common to see an expression like this. This report reports. So report and reports, they are a sign of redundancy. This is very easy to avoid if you review your paper by yourself, but sometimes you can easily skip it. So pay attention to this problem. The next one is actually more important, acronyms. You use many acronyms in the paper. Acronyms should be fully spelled out at its first appearance. When you have it for the first time in your paper, fully spell it. For example, fast Fourier transform is often written as FFT in engineering. But you may have a question. Which is better? FFT followed by fast Fourier transform in parentheses, or fast Fourier transform followed by FFT in parentheses? It's an interesting question. I had exactly the same question in my late 20s, and I asked this question to the instructor in the technical writing course I was taking. So I know the answer, of course. Which do you think is the correct one? Raise your hand if you think FFT followed by fast Fourier transform in parentheses. Nobody? Do you think this is better? Raise your hand. Okay, thank you. Some people are typical Japanese. They don't express their position. Okay, the answer is, it depends. It depends on the case. For example, if FFT is widely used in the field you are writing a paper, you can write FFT followed by fast Fourier transform in parentheses. If your paper is in a field where FFT is not that commonly used, you should first write fast Fourier transform and then put FFT in parentheses after fast Fourier transform. So it depends. It depends on how familiar, how common the word is in that field. Okay, remember, this is a very important thing. And always don't forget to put fully spelled words for each acronym when it appears for the first time in your paper. I have some examples of traps, but because of the time constraint, I will just skip it. There will be more interesting contents in the following pages. All right, now, when you have completed your draft and have it reviewed by your boss, your supervisor, and you're ready to submit, check these things. What is the value of the research in what application? Do you have a clear answer? Do you have a sufficiently clear and concise expression in your paper? What trick makes this value possible? Think about your trick. List all components for the value if there are more than one. How good is the trick with actual evaluation results? Don't forget to put some numerical values so that it becomes clearer. Don't put additional words to too much emphasis, and things like that. The value will be evaluated by the reader. Okay, some more tips appear here in this page. Build your own dictionary and or thesaurus. Collect useful and cool expressions from the papers and the presentations you read or you attended. Just underline cool expressions and copy it to somewhere where you keep these expressions and try to use it in your own paper. It will improve the description of your paper much better, very effectively. Use these as often as possible. This is the point. Without using it, it will not be yours. Consult with a dictionary. It's true always. Today, you have an online dictionary. It's easier to use than flipping pages one after another in a printed dictionary. It's much easier and less time consuming. So don't avoid consulting with the dictionary when you encounter a new or unsure expression or usage. This is a question I often receive. Is it necessary to put an outline of presentation in the beginning of the paper? Today's talk, I had an outline page even though I skipped it. So basically my position is like this. It's not necessary. The answer is no. For ordinary research presentation or ordinary research paper, it's not necessary. However, sometimes it is useful and helpful. It does something good. It may help, like today's talk, like overview presentation, overview talk, or tutorial. The style is not always fixed. So from that point of view, it is kind for the readers or the audience to read the outline of the presentation at the beginning of the presentation or paper. Okay, so this is a summary of what I have already talked about, but I will skip it. So the next topic here is how you can make a good and effective slides for your presentation. So the first thing I would like to say is don't use sentences. Most of the people use sentences, but instead list keywords. Okay? Don't put sentences. Why? Because if you put sentences, it is likely to be longer. It's more space consuming. The slide will be more congested. You need to use a smaller font. And it is harder to read it from a distance. So that is why I suggest keywords or short phrases instead of a full sentence. And between keywords, you can, of course, connect and put some additional explanation by your talk, just like I'm doing today. And redundancy can be fully eliminated if you avoid using a full sentence and always try to use phrases or words. Use big font. The minimum font size I suggest is 24. This is the minimum font size. Always keep it in mind. This is good enough to read from the backmost line of a big room. I am always following this rule, and I always try to make slightly bigger font, like 28 points or even 32. So this is exactly the 24 point size. You don't have any problem even if you are seated in a back seat. So that is a sign. If you use this font size, it's a minimum 1 centimeters in height and width for A4 sheet or letter size paper, or even on PowerPoint presentation. So it's visible enough. If you have too much contents, you are likely to use a smaller font size. So that is a bad sign. If you are using too small font size, check if you have put too much thing in it. If you remove redundancy and you can reduce the content, it is possible for you to use a bigger font. If you cannot make it, in that case, you have much useful, much important information in a single page. In that case, it is suggested to split it into 2 pages so that each page will be much more readable. One more tip about the font: use Gothic and bold. So compare this group and this group. Gothic, and this is a royal and a normal. It's very clear that as the font size becomes smaller, it is more visible to use a Gothic font. So that's why this is recommended compared to this one, more visible from a distance. Eliminate redundant space. It is not recommended to put more things if you have much space. If you have much space, instead, use large figures and large font size. This is what you should do. And even if you have more space, open space, don't put more characters. Think about what is the minimum information to convey what you would like to say. Use colors. This is also important. You should know it. It's effective and helpful to emphasize the point. But attention to color combinations. I will show you some bad examples. Okay, is it easy to read? Of course not. Pale colors in white background or dark colors in dark background. They are not easy to read. You should avoid these combinations because they are hard to read. And also avoid pale yellow, pale blue with white background. It's hard to read. But you may you may have your favorite colors and you would like to use these ones. In that case, you can do that. Change the background color so that you can use the original font color you wanted to use. So always pay attention to the combination of the colors when you prepare a slide. It's not to use simply multiple colors. Always think about the combination. And appeal to the side. Here is a table with equations and more than tens of words. If you had one figure or one illustration or one graph, you can convey much more information. So I will talk more about it. All right. So the next topic from here is how you can convert a table into a figure. Okay. So the purpose of a table. What are the purposes when you insert a table in your paper? Compare something by numbers, compare something by characters, or simply list items. These are probably the purposes to have a table in your paper. So in this case, the first case, use a graph. Compare by number. If you like to compare some things by numbers, use a graph instead. It's possible, always. I guarantee. When you compare something by characters, you cannot convert it into a graph. So keep the table. In this case, also keep the table list items. For example, when you are listing the conditions for your evaluations or experiments, it is not possible to convert it into a figure. So in that case, just keep the table, but otherwise, use a graph instead. And I'm going to talk about how you can convert a table into a graph, an appropriate graph. So here are some examples to keep the table. It's a repetition. Evaluation conditions by listing items or parameters. So this is number 3 case. Multiple methods, it's also number 3 case. And methods plus features, comparison by character, example. So in these cases, it's okay to keep the table, but otherwise always think about converting it into a figure. All right, why? It's friendly, easy to read. So there are 3 components for easy to read. You need to think about these 3 points. Graph is much better than table because it's not necessary to think what each value means. And value comparison takes time. I'm giving an example here. This is a table. It's not easy to understand what each value means. And which one is bigger? You cannot tell it instantly. You need to understand the value and you need to perform comparison in mind. Otherwise, you cannot tell which one is bigger. For example, this one and this one. They are very close to each other. Minimum change of the line of the side. It's very tiring to change the side. If you look at something and look at another point, if you repeat it, you will be tiring. It's not a good thing because you need to refocus when you change the side. That's the reason. So if you have a graph, you can avoid focus repetition. So that's why figure is better. And it's more intuitive. Graphs are more intuitive than the tables. It is not necessary to convert. You can read the meaning directly from the figure, as far as the figure is well designed. So there are some types of figures. Basically, I'm talking about 3 different types. The first one is line chart, so-called line chart. These are examples. Line charts are useful to express a continuous change. In this case, it's a long time. In this case, it's a long year. They're both a long time, but this is second, this is year. They are both continuous along the time. So in this case, line chart is the best choice. The second example, second category, is the stacked bar chart, like this, and the pie chart. They are useful to show the ratios. Okay, so in this case, you have information how big the 100% is. It's also true here. When you are counting the ratio, it is useful to use a stacked bar chart like this or pie chart. Now, the third type is bar chart. Bar chart is useful for simple comparison, discrete values like this. And it is also possible to use the bar chart like this. You may tilt 90 degrees. You may tilt this bar chart by 90 degrees so that it looks like this. This is effective when you have this bar chart in a paper. Usually, papers require 2-column format. In the 2-column format, if you use this, the chart is, this graph is tall and it occupies a large area. However, if you tilt it by 90 degrees, you can make the height of this graph shorter. So it saves time in your paper. So in the paper, this is more recommended. But in the presentation, sometimes this is more intuitive and more recommended. It depends on the case. But in the paper, this form is very useful and it's worth remembering. There are some tips when you prepare a figure. First of all, put a label for axis. It's very common to see figures without labels like this. What does it mean? Is that time? Is that year? Is that weight? What it is? No information. It's also true for these. So put labels like this. This is time. This is magnitude. It's clear. It is often one of the reasons to reject your paper if your figure does not accompany any label, because it is not possible to understand what it means. So be careful. Font size of a figure should be equal to or larger than the font size used in the body. Otherwise, it's not visible. It's quite a common mistake to use much smaller font size so that it's not visible. If it's not visible, it means it doesn't exist. 24 point, again, is a minimum size and recommended. So it's not easy to read these values probably for you. I can read them because I'm standing here closer to the figure, but you should have difficult time reading these values. But if you use 24 points like this, it is visible so that you can convey the information for sure with labels again. And visibility is very important. This is not good, but if you simply increase the font size, it is too much congested. So please notice that there are some skipped values. Even if you decimate some values, it's possible still to understand what it means. So think about how busy the figure is. When you feel it's busy, just remove some values so that it's more visible. It's much kinder for the reviewers and the readers. And you may use different thickness for the curves, for the lines. For example, this is the original figure. It's not easy to read, but in this case, even though the color is the same, the thickness is different from a line to another. You can also use different types of lines, not only the solid line. You may use dotted line, dashed line, dashed lines. It would also help. Always think about how you can increase the visibility. Now, minimum change of the line of sight. What can you do? Legend in the graph is very useful technique. For example, this is the original stacked bar chart. You may easily use it. You may easily make it by, for example, Excel. But it's not easy. For example, what is this? This color is similar to this one or this one. It's not easy. You need to change your eyesight. That's not good. So include the legends within the graph like this. So it's clear. This box represents IFFT plus window. It's more straightforward in this form. And the same thing, you can do that for a pie chart like this. This is the original pie chart, and it is modified like this. So everything comes to much closer to each piece of pie. And here, I would like you to notice that you are repeating the percent sign many times, which is redundant. So put the sign here, which is common to all the pies here. It's not a problem at all because you will understand it in this form. And it's more visible. Okay? So more complex examples. And this is a legend of this graph originally prepared. So first, I put the legend in the graph. Notice the size of the graph. It's much bigger than the previous one. You can make the graph bigger, which is good for visibility. But this is not yet good enough. You can do something further. So use this sign to show some groups and name them. And also, this is a value of a parameter. You don't have to repeat row here. That's a parameter here. You can share this information like this, value of row, so that you don't have to repeat it. Okay, it's much simpler. If you compare the original with this improved form, it's clear which one is more visible, which one is easier to read and impressive. Now, colors of labels, indication lines, and graphs. Intuitive agreement of colors. For example, here you have legend. Make it closer to each line in the same color so that it's more intuitive. For example, to explain the blue line, pale blue line, that it means UK, put UK close to this line in the same color. Here, UK is in black. Now, UK is in pale blue. It's more intuitive. Now, it's getting more and more complex. Okay, so this is a copy from one of the papers written by one of my colleagues. So it shows endpoint estimation accuracy. You don't have to understand what is endpoint, but there are two baseline methods, deep neural networks and LSTM, and the proposed method for different values of parameters. He would like to highlight maybe these two values, but you still don't understand why they are highlighted. In some sense, they look important. So the information or the message of the author is hard to be conveyed in the form of this table. Maybe these values are important. So this is another table representing onset estimation accuracy. So these two are something about accuracies. The first thing you should do is, okay, this is a simple comparison. So let's introduce a bar chart. So the conventional methods, 1, 2, 3, 4 bars here. And for the proposed method, many bars here. And even if you change the value of the row, the performance, the height of blue bars, they don't change very much. Okay, so it shows insensitivity of this accuracy to the value of row. So let's make it in another form. Instead of showing these things, insensitivity to the value of row, your information here is that it is concentrated in the narrow range. Narrow range means they are not different very much by each other. So integrate all these into a single bar and show the range of the variation. And if the range is narrow, that is a sign that it is insensitive to the value of the row. And if you do that, if you do this modification, you don't need all these bars. And it looks like this. It's very simple, right? You have only 4 groups of bars and very easy to convey. Number of bars from 8 to 4, it's 50% reduction and easy to read and compare with no loss of information. What is the information? Okay, the proposed methods are always better than the conventional method with DNN or LSTM. The bars are taller than these, and it is insensitive to the value of the row. So there is no lost message, but it's very easy to read, providing better visibility. So we can do the same thing or similar thing to the other table, like this. Yet another example. It's very similar, but in this case, in one of the figures, I have just converted this table into this graph, and the other one to this graph. This one spans only the negative range between 0 and minus something. In this case, it spans between 0 and 30 something, so it is in the area of perceived values. It is possible to combine these because there is the same value, 0. And the values, the methods are common. This is DNN, here is DNN. This is LSTM, here is the LSTM. And this is proposed, and these are proposed, okay? So you may want to combine these. It's possible, like this. I just tilted these values by 90 degrees, but you can further integrate these. Oh, I'm sorry. So this is the final form. I am sorry. So it's easy. It's more intuitive because the value increases along the time. These are time values to the right. The positive values extend to the right, and negative values extend to the left. It's more intuitive. This is how you express the values generally. So it's much simpler compared to the original table. So likewise, you can apply these techniques or similar techniques to your own table to make it more visible, make it more intuitive, make it more impressive for the reviewers and the readers. If you like, you may check your slide with these check points and check your figure with these things again. Let me repeat it again and again and again. Use minimum 24 point. Always keep it in mind. This is most important. And if you follow this, some additional problems are simultaneously solved. Okay, so it's almost time, and I need to leave some time for questions. This is a summary of the slide preparation, but I skip it, and I will tell you simply the overall summary of my overall talk today. So I proposed or encouraged to follow the slide first theory. First, prepare slides for presentation so that you can establish a good logic, solid logic, which is very effective. And to establish a good logic, follow the three-point analysis to identify the value and the trick and the problem of your research. Relate value and the problem. That is very important, but often violated when I review papers. I notice it. And attention to good logical structure. It is easy to follow without a question or without rethinking, and it is possible to predict what appears next. This is a very important characteristic because you will feel very easy if you can predict what comes up next. And attention to the chart type. Use figures instead of tables, and also pay attention to the chart type. All right, I still have 15 minutes for the questions. Thank you very much for your attention. Now it's time for you to speak. My part is over. Thank you very much.